Welcome to The Explainer. Today we're going to build a kind of mental toolkit, something to help us tackle complexity. We're going to start with a really simple idea and see how it blossoms into this powerful modern discipline. All right, let's just dive right in. It's a question that's probably driven a lot of us crazy at some point. You've got this ambitious project, right? You've got all the experts, the best people in the room, and yet it just fails. Why does that happen? What's the real problem? Well, a lot of the time, the answer is that everyone's so focused on their own little piece of the puzzle, they're just looking at the trees. They're not seeing the whole forest. It's not just about making each part perfect, it's about making sure all those parts actually work together. And that really brings us to the heart of the matter, especially in today's world. Think about modern cars. You've got software, electronics, mechanics, all tangled up. It's what we call the complexity crisis. So here's the problem. When you have all these different teams working on something, what's best for one team, say cutting costs on a specific part, might actually cripple the performance of the whole system. You end up with these huge integration nightmares where nothing fits together, all because nobody was looking at the big picture.
Okay, so to solve this, we've got to go back to basics. We need to start with the foundational idea here. Let's ask a simple question. What is a system anyway?
Basically, it's just a bunch of interacting parts that are all organized to achieve some kind of goal. And the key word there is interacting. It's not just a pile of stuff. The elements can be anything: hardware, software, people, information, you name it. Let's look at a concrete example. Think about a soccer team. It's a perfect example of a system, right? The goal? Win the game. The elements? The players, the coach, the ball. The interactions? Passing, defending, all the strategic plays. The point is, no single superstar player can win the game all by themselves. It's how they interact as a team that actually produces the win. All right, so if everything can be looked at as a system, from a team to a piece of software, how should we think about them? Well, this is where we need a whole new mindset. And that mindset is called systems thinking. It's the core philosophy. You see, traditionally, we try to understand things by breaking them down into their smallest parts. Systems thinking does the opposite. It's about synthesis. It's about understanding the whole by looking at how all the parts connect and interact with each other. So when you adopt this mindset, you suddenly have a new way to talk about complexity. Instead of just seeing isolated components, you start looking for things like interconnectivity, feedback loops, and these really cool emergent properties. Things like teamwork that don't exist in any single player but emerge from the whole system working together.
Okay, so a mindset is great. It's a powerful way to see the world. But how do we actually use it to build stuff? Well, that's where we need a real formal discipline.
And that discipline is called systems engineering. It's basically the structured professional way of applying systems thinking to real-world projects. It's the how-to guide that takes the philosophy and makes it practical, looking at the entire life cycle of a product. Now, a lot of people get this confused with project management. They're not the same thing. Here's the easiest way to think about it. Systems engineering is about making sure you're building the right system. Project management is about making sure you're building the system right, on time, on budget. One is about technical integrity, the other is about process and logistics. You need both. You absolutely need both.
So how does this work in practice? Well, a classic tool is the V model. On the left side of the V, you're going down. You start with the big, high-level user needs, and you just keep breaking them down. You decompose the system into its architecture, then into subsystems, and all the way down to the tiny little components. You're defining everything.
Then you hit the bottom of the V and you start coming back up the right side. And this is the integration and verification phase. You test the individual components, then you put them together and test the subsystems. And you keep going up until you're validating the entire system against those original user needs you started with. It's brilliant, really, because every single thing you defined on the way down has a matching test on the way up.
Now, the V model is fantastic, but in today's world, it can get messy. Imagine trying to manage a project with literally millions of requirements, all stored in different Word docs and Excel sheets. It's a nightmare. The sheer complexity meant that this document-based approach just wasn't going to cut it anymore. The whole field had to evolve. And that evolution is called model-based systems engineering, or MBSE. This is the modern way of doing things. Instead of having information scattered across tons of documents that are impossible to keep in sync, MBSE uses one central digital model as the single source of truth for the entire project. Just think about the old way. You've got requirements in one document, the design in another, test plans in a third. If you change one,
you have to remember to manually update the others. It's a total recipe for disaster. With MBSE, it's all one connected model. You change your requirement, and that change automatically ripples through the design, the analysis, everything. It's a game changer.
Yeah, there's this great saying that really sums up the problem MBSE solves. It's this idea that airplane manufacturers realize their stacks of paper specifications actually weighed more than the plane itself. I mean, when your documentation is more complex than your product, you know you've got a problem.
So to really do MBSE right, you need three things to work together. Think of it like this. You need a language to describe the system. That's often something called SysML. You need a methodology, which is kind of like the grammar or the rules for how you build your model. And finally, you need the tools, the actual software that lets you build and work with that model.
Okay, so we've gone on quite a journey here, right? We've gone all the way from a really simple idea to this powerful modern discipline. Let's just quickly retrace our steps.
First, we figured out what a system even is. Then we adopted the systems thinking mindset to see the big picture. We got practical with the systems engineering discipline to actually build things. And finally, we brought it into the 21st century with the practice of MBSE. See how each one builds on the one before it? It's a logical progression.
This whole framework is how we build better, more complex systems. But here's the final thought I want to leave you with. How can you use this way of thinking, not just to build a better product, but to build a better career? What are the trees you're so focused on that you might be missing the entire forest right in front of you?